This is the lecture for section 9.1, Simplifying Rational Expressions. Okay, to simplify rational expressions, we are going to be crossing out common factors. To do that, you must factor. So, for example, with regular numbers, we have 72, which is 8 times 9. So that's a 9. There we go. Which is also 2 times 2 times 2. That's the 8. And 3 times 3. That's the 9. So see, I factor it. With 48, it's 6 times 8. That's an 8, which is 2 times 2 times 2. That's the 8 times 2 times 3. That's the 6. Okay, now we can cross these out. 2, 2, 2, 2, 2, 2. Okay, can't go anymore. I can cross the 2 3s out. So now I am left with 3 over 2. Now for 24 over 56, 24 is 8 times 3. And 56 is, 9 times 7? Yes, 8 times 7, sorry. Okay, well, right off I can see I can cross out the 8s from the factors. I don't have to keep factoring the prime. Okay, so that leaves me with 3 over 7. All right, 3 plus 4 over 21. I cannot cross the 3 out of the 21 and then say that it's 4 over 7 because you can only cross off factors. So 3 plus 4 is 7. I divide that by 21. I have 7 over 7 times 3. This gives me 1/3. A rational expression is an algebraic expression that can be written as a quotient of two polynomials, P of Q and Q of Q. But Q of Q cannot equal 0. Since division by 0 is undefined, values of the variable that make the denominator of a rational expression equal to 0 are excluded, sometimes called extraneous. I've even heard of them called undefined values. This book calls them excluded values. All right, so example 1, state the excluded values. Okay, this is just looking at what's going to make your denominator 0. Well, find all excluded values. For this first one, we look at this denominator and we say, okay, we do not want x squared minus 1 to equal 0. So that means x squared cannot equal 1, which means that if we square root that, x cannot equal plus or minus 1. Now, after we simplify this, notice the x plus 1s go away. Theoretically, the x equal to minus 1 should work now. But the point being that if it never goes into this equation or this expression, it's never going to end up here. So it's still an excluded value because it's never allowed to even start this process. So we would still have plus and minus. Okay. Simplify this expression and state any excluded value. All right, so I can take a 5x out of both terms. I'm left with x plus 8. Again, I can take a 5, but this time a y out, and I'm left with x plus 8. Okay, so x plus 8 cancels, and the 5 cancels. So that leaves me with x, oops, I like that in purple. That leaves me with x over y, this bit right here. Okay, so now excluded values. I cannot have this equal 0. Sorry, let me highlight it so you can see what I'm talking about. I cannot have this part equal to 0. Right, so that cannot equal 0. Also over here with the y, that cannot equal 0. So I know that y can't equal 0. I also know that this part can't equal 0. So remember I factored it, so I got 5y x plus 8. Okay, well that cannot equal 0, which means that y cannot equal 0, and x plus 8 cannot equal 0. So that means x cannot equal negative 8 either. So I have two excluded values. So how you would state this solution would be x over y. X cannot equal negative 8. Y cannot equal 0. You would have to have all of this in any stated answer. Sorry, it's just here to change slides. Okay, remember that only common factors can be canceled. Okay, factors. Only factors. You cannot, if I have x plus 1 over x, you can't do that. Those are not factors. X is not a factor of x plus 1. Okay, only multiplications can be undone through division. You cannot undo that plus sign. So this is a big fat no-no. All right, when factors are opposites of each other, such as x minus 3 and 3 minus x, we can factor a negative 1 from one of the factors, and it allows you to flip the numbers. So what we're saying here is that x minus 3 is equal to negative 1 times 3 minus x. No, I didn't say that. No. Yes, I did say that. Fine. Right? So if I multiplied that negative 1 in, I would get x minus 3. Okay. What's a better way to say this so that it makes it clearer? Okay. How about this? All right, let's try this one. All right. 3 minus x can be rewritten as negative 1 times a negative 3, which becomes a positive 3, right? Minus 1 times x. But we already have the minus 1 because there's a 1 right here. So it really isn't changing anything. But what I did, hopefully, was separate out this minus 1. Actually, this is going to be plus a minus 1 times x. So hopefully what I did was show you that I have a minus 1 here and a minus 1 there. So I can factor out that minus 1, and I'm left with minus 3 plus x, which can be rewritten x minus 3. So see, I have managed to flip this around and go from 3 minus x to x minus 3 with a negative out front. All right, so that's one of the tricks we use if we come up with factors that are opposites of each other, like that. Okay, so now we are simplifying and then leaving the answers in factored form. All right, so 126 is 2 times 63. So I can factor out the 63. I also have 2a squareds in each term. So that leaves me with an a minus 2. Here I can factor out a 21a, and that leaves me with a plus 2. Yeah, I can't do anything with that a minus 2 and an a plus 2, so I'm pausing to just double check my math. Yeah, because of a minus and a plus, I've got a problem. So I can't do anything with those two. But what I can do is I can get rid of this a and get rid of that 2. It becomes a 1, so it's just a. And then 63 is 3 times 21. So I can get rid of the 21, and the 63 is going to become 3. So what I end up with is 3a, a minus 2, over a plus 2. And then I'm stuck with that. I can't do anything about that a minus 2 and the a plus 2. They aren't opposites, because a is positive in both. All right. Moving along. Simplify stating any excluded values this time. All right. Well, I can pull out an x squared from each term, leaving 6x squared minus 5x plus 1. And in the denominator, I can pull out an x. I can also now state part of my exclusions. I have to simplify this to see if I gain any more exclusions, any more excluded values. All right, I have to factor the 6x squared minus 5x plus 1. So I end up with, let's see, 2 and 3. So I end up with, oh, wrong color, apologies. I end up with 2x, hang on. I end up with 2x minus 3 and x minus 1. That doesn't work. Oh, 3x, that's my problem. And what is a 3? This 3 becomes, sorry, it was supposed to be a 1. So it becomes 2x minus 1 over 3x minus 1. All right, now my denominator, I have 1 minus 2x. Oh, I still have an x on top, but I get rid of this bottom x because of the squared. Now this is 1 minus 2x, so I'm going to make this minus and then flip everything around. 2x minus 1. Now I can get rid of that. So my final answer is minus x times 3x minus 1. No denominator anymore, but these are still excluded values because they would never enter the function. Okay, they would not be allowed to enter the function. Oh, was it? That was it. Okay, and we are done. Have fun with your homework.